Okay guys, this is Worms Maths Academy having a crack at Section B from Northern Hemisphere Exam 2 for Specialist Maths. Answer all questions in the space provided, unless otherwise use an exact answer, make sure it's exact. In questions where more than one mark is available, appropriate workup must be shown. Unless otherwise stated, the diagrams in this book are not drawn to scale. Take the acceleration due to gravity, have a magnitude of g meters a second where g is 9.8. Okay. So I've got a function. Our rule is 10 arc cos. Of course, if you don't remember, that's cos inverse of 2 minus 2x. Okay, I would have looked at this in reading time and worked out whether I wanted to define it or not. So let's have a look. Usually what I do is I put down my domain, which is -1 to 1 for cos inverse, and my range, which is 0 to pi. And then I work out what transformations have occurred. So it's been dilated by 10, so it's going to go between 0 and 10 pi. It has been translated. We can say that that is negative x. Oops, what am I doing? Negative 2x minus 1. So it's been reflected in the y-axis, which will change the shape. It's been dilated a half from the y-axis, which would make it -1/2 to 1/2. And then it's been translated right 1, which would make it 1/2 to 3/2. So that's my domain, and that's my range. And it's been reflected. So what does a cos inverse graph look like? Cos looks like that, so cos inverse looks like that. When it's reflected, it's going to look like that, but it's been moved to the right. So now it starts at 1/2. We know it's going to finish at 3/2, and it is 10 pi, which is 31. So let's say this is here. Label the endpoints with their coordinates. So 1/2, 0. This is going to be 10 pi, and no, it's going to be 3/2, 10 pi. The halfway mark is going to be 5 pi, which is 15, around 15. What shape did we say it's going to have? It's going to look like that. Looks like a cos inverse graph, that's good enough. Okay, sketch f over its maximum range. Instead of x, label the endpoints with their coordinates. So 3/2, 10 pi, 1/2, 0. You could have also done that on your calcs. Write down a definite integral in terms of y that gives a volume of the vase. Okay, so we've got 10 cos inverse 2 minus 2x. So y equals 10 cos inverse 2 minus 2x. We want to find its inverse because we want our function in terms of y, and it'll be pi from 0 to 10 pi, my upper value. Now here, if we swap x and y, we're going to get x on 10. So y on 10. Yeah, so we do it in terms of y. Okay, so I get y on 10 cos x equals y on 10 cos of y on 10 minus 2, and then divided by -2, so I get -1/2 plus 1. Okay, so that's x, so x squared will be all of that squared. So if we go from pi, 0 to pi, 10 pi, our volume is 0 to 10 pi, -1/2 cos y on 10 plus 1 squared dy. Write down an integral that gives you, okay, find the volume of the vase. Okay, so we've got negative a half cos y on 10 plus 1. I forgot the pi. Don't forget your pi or you'll stuff it up. Okay, so back to our cas. Pi times integral 0 to 10 pi of, what was our function? Negative a half cos y on 10 plus 1. Negative 1/2 cos x on 10 plus 1 all plus 1 all squared dx. Negative a half cos x on 10 plus 1 all squared dx. That's not exact, and that should be in radians. 45 pi squared on 4. Okay, water is poured in a rate of 20 meters cubed per second. So that's dV dt is 20 centimeters cubed per second. Find the rate, centimeters, which the depth of the water. So we'll say dH dt, given h equals 5 pi. So we need dV dH, which is y in this, yeah, h is y. So, so we want to know the volume from 0 to 5 pi. So dV dH, yep. Okay, so from 0 to 5 pi. No, what am I thinking? We don't want that. We want our that is dV. This is the original function. So the volume equals 5 pi so that is dV dy, because we know what v is in terms of y, so dV dy is that when I derive it. Let me say given x equals 5 pi, pi on 4. What? Negative a half, that's not a minus in between. Pi. That is dV dy, because when we integrate it we get the volume, so that is the derivative, and then when the height is 5 pi, when the depth is 5 pi. So we know dV dH is pi 1 minus cos y on 10 squared when y equals 5 pi, which is what we just found out. dV dH is equal to pi. So we know dH dt is equal to 1 on pi, that's dH dV, times 20 centimeters cubed per second, which is 20 on pi. What's that? Centimeters a second, because it's a height. So it's increasing at 20 on pi centimeters a second. The vase is placed on the table. B climbs from the bottom of the outside of the vase to the top of the vase. What is the minimum distance that B will need to travel? Give your answer in centimeters correct to one decimal place. So we just want the arc length of, what is that function? It was, so we've got a function in terms of f. We can go from 0 to 2 pi, so to 10 pi. So 0 to 10 pi of 10 cos inverse of 2 minus 2x. Oh, what am I doing? I just want that function. Come here, you stupid thing. Okay, cut, clear, interactive calculation, line, arc length, paste, 0 to, no, it was from a half, my x value, to 3 divided by 2. Oof, that's nasty. It doesn't want to work it out for us. I wonder if it's because of the endpoint. Let's try put in 4999. Oh, stupid thing. So let's try go 4999999 4999999, and this one will go to 0.500001. Okay, 31.4355. 31.43 was 4 centimeters. Now, is that right? What could we do? We could try use the inverse. So, what was our inverse again? We could integrate so negative 1/2 cos of x plus 1. That was that inverse, wasn't it? Interactive calculation, line arc length 0 to 10 pi, 33.29. Is that what I just got? No. Did I do the inverse right? Negative 1/2 cos x on 10. X on 10. 31.43. Okay, so I'm pretty confident that's what our answer is. 31.4 centimeters. Stupid calculator doesn't work it out the other way. Okay, show the Cartesian equation of this complex line is given by that. That's a bit nasty. Okay, we could just use square root x plus 1 squared plus y squared equals x plus 1/2 squared plus y minus root 3 on 2 squared. So I get x squared plus 2x plus 1 plus y squared equals x squared plus x plus 1/4 plus y squared minus root 3 on 2, root 3 on 2, root 3y, and then plus 3 on 4. Okay, so x squared, I've got an x on this side, that's those, y squared, here I've got 1/4, 3/4 and 1, they cancel. So all I did was I'll leave the x on that side, and I get equals negative root 3y, therefore y equals negative 1 on root 3x. Find the points of intersection of L and the graph of the relation z bar equals 4. That's a circle radius 2, isn't it? X plus yi, x minus yi equals 4. X squared And the y, x, y, I cancels, so plus y squared equals 4. So that's a circle radius 2. Okay, if I sub y into here, I get x squared plus x on root 3 squared. I'm not going to worry about the negative because when I square it becomes positive. That equals 4. So I end up with x squared plus x squared on 3, which is 4x squared on 3 equals 4. So x squared is equal to 3. Therefore x equals plus or minus root 3. Find the points of intersection. It doesn't say coordinates, it says points. So I'm going to give it as a coordinate because it's not very clear. Okay, so we've got negative root 3, but it's not that hard to find anyway. So if I put negative root 3 into that, I'm going to get positive 1. And root 3, if I put that into there, I'm going to get negative 1. Oh, in Cartesian form. Yeah, so it just means coordinates. Okay, sketch L and the graph of that relation. So we're going to go it's pretty dodgy, but this thing's got a really nice function where if you draw a circle, stupid thing. Bring it over here and try and resize it down. Okay, so there's my circle radius 2. Negative 1 on root 3. Y equals negative 1 on root 3 x. So as I said, tan theta is negative 1 on root 3. 1, 2, root 3. So it's got to be that. So it's pi on 6. So that's that line there, which is y equals negative 1 on root 3 x. Okay, and then we've got sketch it. So that's L, x squared plus, I could relabel it, z bar equals 4. Another line L in the fourth quadrant being expressed as the arg of z equals a. We just found out what a was. State the value of a. So a is equal to negative pi on 6. That's that angle. Find an area enclosed by the graphs of L and the graphs with those relations. Okay, closed by L, the graphs of the relations z. Okay, so the circle and arg z equals pi on 3. Okay, so I'm going to draw this in a different color so I can work out what the hell they're talking about. So L, it's there. Arg z equals pi on 3. That's pi on 6, so pi on 3 is there. And z1, the circle, and the r part of z equals root 3. So that's root 3, and then that as well. Okay, so if we have a look at this, we've got two distinct areas that I can see. We've got a triangle here. That length there, we just found the coordinates for negative 1 and 1. So that length there is 2. We know that length's root 3. So my area, what colour pen was I working with? My area is a half times 2 times root 3, which is this triangle here. And then my other one here, that's 30 degrees out of a full circle, so it's 1/12 of a circle of radius 2. So plus 1/12 times pi times 2 squared. Okay, they cancel, so it's root 3. I'm going to get 4 pi on 12, which is pi on 3. Does it give us any units? Units squared. Kind of sucks because it's going to rub out my nice diagram. Okay, so that's that area that it just asked us for. It continues. A straight line L can be written in the form Z K conjugate Z. K is find K in the form R cis theta, where theta is the principal argument of K. Okay, so x plus yi equals K, x minus yi. Oh, but we want it in cis form, so it's going to be easier to do that, I reckon. R cis theta is equal to K R cis negative theta. Handwriting's pretty crappy there. Oops. K, stupidly, R cis theta. Okay, so we get K is equal to R cis theta on R cis negative theta. That will cancel, and I'll get cis. We subtract those angles, so 2 theta. So K equals cis 2 theta. We worked out what the angle was, didn't we? That angle's pi on 6. Right, so we know that angle's pi on 6. So K equals cis 2 pi on 6, which is cis pi on 3. So K is equal to cis of, it's negative pi on 3, on 6, negative pi on 6, negative pi on 6. So it is cis of negative pi on 3. That makes sense because it's rotated, negative pi on 3. Just thinking, could you give the argument as being, you couldn't give it as 5 pi on 6 because if you went 5 pi on 6, if you multiplied it by 2, then it would give you the wrong angle. Like it isn't within the domain that's required. Okay, question 3. 200 K rests on a smooth plane. Okay, so it's got no friction, theta degrees. The horizontal and external force F newtons acts up the plane. So that's F. There's my normal force. Not that we really care because it's got no friction. There's my angle, 200 G. That way, theta's there. Okay, so this side is going to be 200 G cos theta, and this is going to be 200 G sine theta. Find F in terms of theta. So if it's in equilibrium, F minus, well, we can just write the answer. It's just going to be 200 G sine theta. Okay, the magnitude of the external force F is changed to 780 newtons, and the plane is inclined at 30 degrees. Taking the plane direction view, find the acceleration of the crate. Okay, so down the plane is 200 G sine 30 minus my upwards force, which is 780 newtons, is equal to mass 200 times A. Okay, that's going to be 100 G because that's a half. 100 G is 980 minus 780 is 200 equals 200 A. So therefore A equals 1 meter per second squared. So that's the acceleration down the plane. Okay, on the axis below, 1 meter per second squared. Sketch it, velocity time graph, 4 seconds of its motion. Okay, so it's not 0 and 1 meter per second. So 1, 2, 3, 4. So velocity time graph of the crate in the positive direction. Okay. Calculate the distance the crate travels in meters in its first 4 seconds of motion. So that's just the area under the graph. It's the area under the graph, but distance is 1/2 times 4 times 4, which is 8 meters. No, half of 4 is 16, yeah, 8 meters, is it? Velocity time, has it got units anywhere? Oh, meters, yeah. I looked there for it, I couldn't bloody find it. Okay. Starting from rest, the crate slides down a smooth plane inclined at A degrees to the horizontal. A force of 295 cos newtons up the plane. A parallel plane acts on the crate. Okay, so let's have a look. There's my plane. 8 degrees to the horizontal, so there's alpha. That's alpha. That is 295 cos alpha. That's my normal force. Okay. If the momentum, and this is going to be 200g, so that's going to be 200g sine alpha, and that will be 200g cos. I could be working out all this stuff for nothing. Okay, if the momentum of the crate 800 kilogram meters a second, after having traveled 10 minutes, find the acceleration. Okay, 800. Okay, what do we know? P equals mv. So my momentum started at 0, but now it's 800. So 800 is equal to mass times velocity. So 200 times v. So v equals 4 meters per second. Okay, find the acceleration of the crate. Okay, so what do we know? S is 10. We know v, find the acceleration. We know u is 0. We know v is 4 meters a second. And what do we want to find? A. Okay, so VU2 as v squared equals u squared plus 2as. So 16 equals 0 squared plus 2 times s, which is 20, 20a. So a equals 16 on 20, which is 4 on 5 meters per second squared. Okay, it's continuing the question. Okay, find the angle of inclination of the plane if the acceleration down of the crate down the plane is 0.75 meters per second. Okay, so it's going down. Okay, so 200g sine, that wasn't all in a waste up here. 200g sine alpha minus 295 cos alpha. Cos alpha is equal to mass times acceleration. So 200 times 0.75. I think we shall go to the CAS, because it says answer in degrees to 1 decimal place. Okay, so 200 times 9.8. 200 times 9.8 sine x minus 295 cos x. X equals a quarter, 3/4 of 200 is 150. And let's select all interactive events, solve for x. Eq radians, it's got to be in degrees. And our angle's not going to be greater than 90. So given 0 is less than or equal to x, which is less than or equal to 90, 12.89. Was it to one decimal place? So alpha equals 12, can't even write 12.9 degrees to one decimal place. Yay, that question's over with, thank God. Okay, a basketball aimed through a ring of scenario 4.5, release the ball 3. Okay, so that's 1.5 off the ground, that's 3, so this is going to be 1.25, and that distance there is 4.5. Okay, ball is really... Position vector of the ball is given by that, which we could have worked out if we integrated A twice. Okay, for the first shot at goal, V equals 7 meters per second, and A equals 45. To reach its maximum height. So its maximum height occurs when the derivative equals 0. Do we define this thing? I'm not going to bother. Okay, so V is 7, alpha is 45. So we can say R of t is equal to 7, cos of 45 is root 2 on 2. 7 root 2 on 2 t, I, plus 7 sine, that's also going to be 7 root 2 on 2 t, minus 4.9 t squared, j. Okay, so velocity, we only care about the vertical component. Oops, bloody hell. Okay, so v, I'm going to say j of t equals 0. Therefore, 7 root 2 on 2 minus 9.8 t equals 0. So 7 root 2 on 2 minus 9.8x equals 0. Interactive event, solve for x. Oh, 15 root 2 on 5 root 2 on 14. Where'd it go? That looks good because our solution's supposed to look like that. So find the time. 5 root 2 on 14, what is it, seconds? Find the maximum heights above floor level reached by the ball. What? Okay, so we'll say R, J of 5 root 2 on 14 is equal to, so 7 root 2 t minus 4.9. 7 root 2 on, what was it, on 2 times that minus 4.9 times that squared, 5 on 4, 5 on 4. So that's that component. Oh, that's the same as that. So max height is equal to 5 on 4 plus that's 7 on 4. Which is 3 meters. So this first throw only goes to the same height as what the basketball ring is, which is a bit stupid. Okay, give the distance to the center of the ball from the ring 1 second after release. Maybe I should have defined it. Okay, 7 root 2 t. So 7 root 2 on 2. 7 root 2 on, yeah, that's that bit. So that's 5 on 2. 5 on 2. This is after... Oh no, I want it after 1 second. What am I doing? So I sub in t equals 1. So I get 7 root 2 on 2. 7 root 2 on 2, comma. Now after 1 second, it's 7 root 2 on 2 minus 4.9 and then plus 1.75. So 7 root 2 on 2 minus 4.9 and then plus 1.5. So that's the ball. And the rim is 4.53. Okay, to 2 decimal places. And what's that going to be? So 7 root 2 on 2, 7 root 2 on 2, minus 3.4. Yep, 4.53. Okay, so 4.5 delete. Square root 4.5 minus my x value, 7 root 2 on 2 squared plus 3 minus my y value, which was 7 root 2, bracket there, 7 root 2 on t, 7 root 2 on 2, minus 3.4, squared. Okay. That minus that. I just want a bloody answer. 1.51. Did I stuff something up? Was that 1.5? 1.75. Which means that's 3.15. So D 1.28. How many decimal places? 2 decimal places. 1.28 meters. For the player's second shot at goal, V equals 10 meters a second. Find the possible angles of projection for alpha for the center of the ball. Okay, so R of t is 10. What's the formula? T cos alpha I plus 10 t sine alpha minus 4.9 t squared j. Okay, so it's got to go through. So my I component, 10t cos alpha that's got to equal my 4.5 meters, and my j component, 10t sine alpha minus 4.9 t squared, that has to equal 1.25, because I've got to go across 4.5 and up 1.25. Okay, so let's see if we can solve them on the CAS. Because there's two unknowns. So, okay, 10 times y. I'm going to say y is t, cos x equals 4.5. 10 y sine x minus 4.9 x squared. No, that's t y squared equals 1.25, and we want to solve for x comma y in degrees. What the hell are all these answers? Degrees, real decimal, 389, 255, 75.84, 29.67. Can we say, given 0 is less than or equal to x, which is less than or equal to 90? And do the same here. What? What? What have I done? 905. 1.25. So if we bring that down, let's copy this, edit, select all, copy, edit, clear all, edit, paste. Okay, can we go given 0 is less than x, x is the angle, which is less than 90, 29, 75, so it's got to be 29.67. What does it want the answer to? Alpha is equal to degrees to one decimal place. So 29.7 and 75.8. The only problem is, will it be above the, because if you project it at 29 degrees, will it actually go above the bloody height of the thing? That's something we could look at later if we need to. So 29.7 degrees, 75.8 degrees. Okay, for the placeholder, angle of projection is that. Find the speed required for the center of the ball to pass through the center of the ring. Find the speed. Okay, so this time we're going to use the same thing, but that's 60. That's 60. And we'll say that that's x. And that's x. And there's no restriction on that. So 7.78. 7.787. How many decimal places did it want up? This is annoying. So VT cos of 60 is 1/2. VT on 60 on 2 is equal to 4.5. And then sine is root 3 on 2. So VT root 3 on t, 2 minus 4.9 t squared is equal to 1.25. Solve for VT. Okay, and we get 7.V equals center of the ring. Give your answer. 7.8 meters per second. So that's when t equals 60 degrees. I hope that's right. I'm not 100% sure though. Okay, we can always come back to it if we've got time. Alright, so we've got question 5. I don't know how long this is taking, it feels like it's a long exam. Question 5, we've got a beam here and 2 meters apart, so that's 0, that's 2. The deflection y meters of the beam downwards distance is x meters from the support. Okay, so that's positive downwards, I'm thinking that's what it's saying. Alright, given that both the inclination dy dx and the deflection of the beam from the horizontal x equals 2 is 0. So dy dx equals 0 and y equals 0 when x equals 2. Okay, so we've got 80 d squared y dx squared is equal to that. So 80 dy dx is going to be equal to the integral of 3x minus 4 dx. So 80 dy dx is equal to 3x squared on 2 minus 4x plus c when x equals 2 dy dx equals 0. So I get 0 equals 3 4s as 12 on 2 is 6 minus 8 plus c equals 2. So 80 dy dx is equal to 3x squared on 2 minus 4x plus 2. Therefore 80y is equal to the integral of 3x squared on 2 minus 4x plus 2 dx, which is equal to 3x cubed on 2 times 3, so it's going to be x cubed on 2 minus 2x squared plus 2x plus d. Remember to use a different parameter. Okay, when x equals 2, y equals 0. So 0 equals 8 on 2, which is 4, minus 2 times 4, which is 8, plus 2 times 2, which is 4, plus d. So therefore d equals 0. Therefore 80y is equal to x cubed on 2 minus 2x squared plus 2x. X cubed on 2 minus 2x squared as required. How many marks is that? 2 marks, what a pain in the ass. Okay, find the angle of inclination of the beam to the horizontal at the origin. Give your answer correct as a positive acute angle in degrees. Okay, so we want dy dx when x equals 0. So 80 dy dx when x equals 0, dy dx equals 1 on 80 times 0 minus 0 plus 2, which is 1 on 40. Of course, that's giving it as positive because the function itself is like positive displacement, so it's sort of going, it's thinking the other way. Okay, so here we know tan theta is equal to m, which is equal to 1 on 40. So therefore, theta is equal to tan inverse 1 on 40. Let's clean up a bit. Tan inverse 1 divided by 40 degrees, 1.4 degrees. And that makes sense because it's really small. 1.4 degrees. Because you can see the angle isn't going to be very much at all. Find the value x in meters where the maximum deflection occurs and find the maximum deflection in meters. Maximum deflection. So we want to know when the gradient when the maximum deflection. So I guess the deflection y meters of the beam is measured. Okay, so we want to know when dy dx equals 0. So therefore, dy dx is 3x squared on 160 minus 4 on 80, which is minus x on 20, and then plus 2 on 80, which is 1 on 40. So therefore, okay, so let's just write it, 3x squared on 160 minus x on 20 plus 1 on 40, x on 20 plus 1 on 40 equals 0. Let's solve for x. So x equals 2 or 2/3. As at 0, at 2, zero deflection. Okay, so when x equals 2/3, find the maximum deflection. So it's going to be that 1/2 x cubed, 1/2 x cubed minus 2x squared plus 2x given x equals 2/3 divided by 80, so 1 on 135. When x equals 2/3, y equals 1 on 135 meters. Okay, find the maximum angle of the beam to the horizontal part of the beam where x is greater than 1. Okay, so there's x is 1. These are the angles it's going to make. It's going to be somewhere here. So we want to find out the maximum gradient when x is equal to 1. Is it the original function? Copy. Got to divide it by 80 though, I think. 1 divided by 80. Bracket, edit, paste. Okay, we want it between 0 and 2. 0 to 2. Zoom. Auto. Okay, but that graph is the opposite, it's negative. So, zoom, auto. So there's my graph. No, I want to know when the maximum gradient occurs. So, if we derive that, dx of that function okay, the maximum analysis G solve max. Okay, x equals 4/3. When x equals 4/3, what does y equal? Let's select all. Edit, paste. Clear all. Okay, go back here. Edit, select all. Edit, copy. Edit, paste. Given x equals 4 divided by 3. But it wants an acute angle. Hang on. I want dy dx. So I want that. I want the gradient ddx of all of that given x equals 4 and 3. So dy dx equals 1 on 120. Tan theta is equal to 1 on 120. Therefore, theta is equal to tan inverse of that. Just give me the bloody answer. Half a degree. Correct to 1 decimal place, so 0.47, so 0.5 degrees, which makes sense, it's small. Hopefully. Have I skipped anything yet? Surprise. Okay. Coffee machine dispenses coffee concentrate and hot water into a cup of black coffee. The volume of coffee concentrate dispensed is normally distributed with a mean of 40 and a standard deviation of 1.6. So mean of coffee is 40, and then standard deviation of coffee is 1.6 ml. Independent volume of coffee concentrate. The volume of water dispensed normally with a mean of 150. So mean of water is 150, and then standard deviation of water is 6.3. Okay, state the mean standard the total volume of liquid. So E of C plus W, we'll say, is 190 mil, and then so you could say mu of the volume, and then sigma of the volume. So we've got a 1.6 squared plus 6.3 squared, and then square root it. 1.6 squared plus 3.6, was that what it was? Bloody hell, 6.3. Dyslexic. 0.3 squared, square rooted. 6.5 mil, so 6.5 mil. Find the problem that overflows a 200 ml cup. Okay, so let's say x is not binomially, it's normal. 190, and then 6.5 squared. The probability that x is greater than 200. Okay, so interactive distribution, continuous, norm CDF, 200 to 200, infinity, 6.5 and 190. It's going to be reasonably low. What did I want the answer to? 3 decimal places, 0.62. Suppose the standard deviation of the volume of water dispensed by the machine can be adjusted, but the mean volume of the water dispensed and the standard deviation of the volume of coffee concentrate cannot be adjusted. Find the standard deviation of the volume of water dispensed. It is needed to have a 1% chance along black coffee overflowing. Oh, bloody hell, this is way too much to think about. Okay, so let's say the expected value of coffee plus water is 190 still, but our variant of, our standard deviation of coffee has to stay the same, doesn't it? Standard deviation of the volume of coffee. So of coffee is, what was it, 1.6? The standard deviation of water, let's call that A. We know the variance of coffee plus water is equal to 1.6 squared plus A squared. So the standard deviation of coffee plus water is the square root 1.6 squared, 2.56, 2.56 plus A squared. So that's my standard deviation. Okay, 1% chance of overflowing a 200 ml cup. So the probability that Z is greater than B is equal to 0.01. Therefore, B is equal to, so inverse norm, let's go left, 0.99. 2.326. 2.326. So therefore, 2.326 is equal to x minus mu on sigma square root 2.56 plus A squared. So therefore A to 2 decimal places. Okay, so it's 10 on top. 2.36 equals 10 on square root 2.56 plus x squared. Solve. Okay, it's not going to be negative. 3.9897. What do we want it to? 3 decimal places? Oh no, 2 decimal places. 3. 3.99. A is equal to 3.99. I guess it's milliliters. I have no idea if that's right. I guess if we put 3.99, so square root of 2.56 plus 3.99, and then 190, and we said, what's the chance of being greater than 200? Okay, so let's try that. So the square root of 2.56 plus that squared. Okay, that's my standard deviation. And 190. Distribution continuous norm CDF. Distribution continuous norm CDF. So that's my standard deviation. 4.29858,324. My lower is 200. My upper is infinity. And my mean is 190. So this should only be 1%. Perfect. Close enough to 1%. Okay, so I think we did that one right. Oh, this is another question. 7 questions. I haven't seen that before. Okay, according to medical records, the blood pressure of general population, males aged 35 to 45, normally distributed with a mean of 128, the standard deviation of 14 reaches. The male teacher's blood pressure, general population of males. Higher. 49 males, so N is 49. X bar, is 133. Mu is 128. Sigma is 14. 49 to, okay, state the two statistical mean at 5% lower. Okay, so where our H0 is that the mean is 128, and our H1 is that teachers have higher blood pressure, which is greater than 128. The probability that X bar is greater than 133 given mu is equal to 128 is equal to the probability that Z is greater than 133 minus 128 on 14 divided by root 49, which is the probability that Z is greater than 5 on 14 on root 49. 14 on 7 is 2, so 5 on 2. Okay, so the probability that Z is greater than 5 on 2. Interactive distribution continuous. Z is 5 divided by 2. Infinity 10.0062. Therefore, the p value is less than 0.05. Hence, as the p value is less than 0.05, we can reject the null, we can reject H0 at the 5% significance level, hence is it male teachers? Male teachers have higher blood pressure. Okay, find a 90% confidence interval for the mean of the blood pressure of all male teachers using a standard deviation of 14. So 90% confidence interval. Give your answer correct to the nearest integer. Okay, so 14. So mu is 133. Confidence interval for the mean blood pressure of all male teachers. So we want to try and work out what the population would be. So mu is 133, n is 49. Standard deviation is 14. 133, 49, 14. That's going to be right. Interval. Confidence level is 0.9. Sigma was 14. X bar is 133. N is 49. 129.7, 136.3. So to the nearest integer, 130 to 136. And we're done. 90% confidence interval. So we did that. State your conclusion with reason. And so as a PV is less than 0.05, we can reject H null at the 5% significance level. Maybe I wouldn't write that. I'd just say that we can reject. Don't want to give too much. 3.990062, so that's our mean and standard deviation of the volume. That's right. Done. Done. I think that's right. Still not sure on that. Because what would the path be if I had 29.7? So 10t cos 29.7. Clear all. Okay. So 10 times cos 29.7 times t, and then 10 times sine 0.7 times t minus 4.9 t squared. Initialize. I don't have anything. Sketch. Degrees. Real. Oh, I stuffed it up. So it should go through 4.5. Maybe it's because T. Where'd it go? T goes to 360. So we go 0 to 20. 0 to 20. Don't think I need to put degrees in there. Cos alpha, sine alpha. I use the right t's. T, t, t squared. Sketch. What was the other answer? It's only 5.8. So it's supposed to be in radians. Okay. That looks better. So where's the point? 4.5. Trace. T is 4.5. Oh, bloody hell. So how to do with this? What was it? 27.9. I've got to convert it to radians to put it in there. Oh no, you can just put 27.9 degrees with the degree symbol, and that'll convert it. So that would be 4.5 and then 1.25. I guess it's gone over the height of the ring. I think it'd smash into the ring, but anyway. It's a bit stupid, I don't think. You wouldn't get a goal. It would hit that spot if there was no ring in the way. So we answer everything else. It's weird how you had to. That wouldn't do that integration. Yeah, that's it. Section B. Hopefully it's all right. I probably didn't use the CAS as much as I should have. Seems to be like there was missing like vectors and I don't know. Just seemed like a different exam to usual. Anyway, hopefully you want to write it, and hopefully this makes sense. Yeah, hopefully you got it. See ya.